Hi, ladies and gentlemen. We are looking at notes 2.6, which is on characteristics of polynomial functions. And everything that we've done so far this unit is really going to get pulled together with this topic right here. This topic requires us to be able to apply everything that we've learned so far. Okay, so let's take a look at question number 1. It says, use the characteristics of polynomial functions to graph the following function. So right here, our function that we want to graph is right here, y equals negative x to the power of 4 plus 5x cubed minus x squared minus 21x plus 18. We have a lot of room right here to do our work because we have quite a bit of work in order to be able to graph this out. Since it's not quadratic, it's a lot more extensive than what we would do with a quadratic function, okay? So if you notice, there are 3 key things that we need to look at. We need to find our roots. We need to find the y-intercept, which is super easy, so that part shouldn't be so bad. And then we need to look at our end behavior, which is something that we've already discussed quite a bit. So let's go ahead and do this. Let's do the roots first because that's the hardest part. Let's get it out of the way, okay? So the first thing I'm going to do is I'm going to make a list of some possible a values, okay? And remember, in order to figure that out, we want to do p over q right here, but q can be 1, so I'm just going to look at values of p just to start off with, okay? So our p value right here is 18, so I'm going to look at factors of 18. Well, 1 is a factor, so I'll say plus or minus 1 will work. 2 is a factor, 3 is a factor, 4 is not, 5 is not, 6 is a factor, 9 is a factor, and 18 is a factor, okay? And I'm going to go ahead and just start plugging and chugging and figuring out some of these values. So the first thing I'm going to do is I'm going to figure out what f of, let's try -1 is. F of -1, when I plug it in, will be -1 to the power of 4, right? Plus 5 times 1 cubed minus 1 squared minus 21 times 1 plus 18. Well, when I evaluate all that stuff, I end up getting that f of -1 is equal to 32, which means that a cannot be 32, or sorry, cannot be -1. However, I am going to use that. I'm going to keep that as a possibility because I think that's going to help me out in the future because we're talking about graphing functions. So actually having a coordinate, I think, is going to help me out. Okay, so we tried -1. So let's go ahead and try 1. So take a moment and try 1, plug it in, see if it works for you or not. Then come back to me and see if your answer agrees with mine. Okay, so when I do f of 1, I end up getting 0, which means that the remainder is 0, which means it is a factor. So therefore I can say that x minus 1 is a factor. I'm going to do a couple because this is x to the power of 4 and I want to get down to a quadratic. So I'm going to try a couple examples until I find at least, I'm going to try a bunch of numbers, sorry, until I find at least 2 examples so that it'll bring me down to a quadratic that'll be a little bit easier to solve, okay? Next one I want you to calculate is f of 2. Let's see what you get. Go ahead and calculate it, press pause, and then come back to me to see if you get the same answer as me. Okay, so when you evaluate f of 2, you should get -4, which is not what we want. Remember, we want a remainder of 0, so that doesn't work. So let's try f of -2 next. Okay, so again, go ahead and evaluate it before you come back to me to check to see if your answer is correct. Okay, so we should end up getting f of -2 is equal to 0. So it does work. Therefore, we can conclude that x plus 2 is a factor. Okay? So now that I've gotten 2 factors out of my 4 possible factors, it's not necessarily going to have 4 factors, but I know that I have 4 possible factors, I can go ahead and start doing my division. But before I do that, I'm going to rewrite the problem right here. So I know that f of x is equal to -x to the power of 4 plus 5x cubed minus x squared minus 21x plus 18. But what I'm going to do to make my life easier is I'm going to factor out a -1. Because when I want this in factored form, it's so much easier if my leading coefficient is positive. So this is x to the power of 4 minus 5x cubed plus x squared plus 21x minus 18. Okay, so I can go ahead and do my synthetic division for my two factors. So my first a value that we got here was 1. So let's go ahead and do our synthetic division of 1. We're going to use our coefficients inside of our brackets here. So we've got 1, -5, 1, 21, and -18, and I'm going to use 1 in my synthetic division. Bring down this 1 right here. 1 times 1 is 1, -5 plus 1 is -4. -4 times 1 is -4. Add those guys together, I get -3. Multiply -3 by 1, and I get -3. 21 minus 3 is 18. 18 times 1 is 18, so I get a remainder of 0. So that's good. I'm going to keep going though. So my next factor that we got was x plus 2. So I'm going to go ahead and do synthetic division again. So I'm going to divide my new coefficients that I have here without my remainder because I don't need that anymore. I'm going to use synthetic division with these coefficients as well as with the number -2. And I'm going to use -2 in my synthetic division. So I'm going to bring down this 1. 1 times -2 is -2. -4 and -2 put together is -6. -6 times -2 is +12. -3 plus 12 is 9. 9 times -2 is -18. Sorry, I apologize. This should have been a +18 that we brought down right here. So now I have a remainder of 0. So that works for me. So what does this all mean? Well, f of x therefore will become, I keep the -1, okay? I know that I have x minus 1 as a factor, and I also know that I have x plus 2 as a factor. And then what do I have left over? X squared minus 6x plus 9. Okay, so that means that I can say that f of x is equal to -1 times x minus 1 times x plus 2. And let's go ahead and factor this right here. Well, when I factor this, I'll use x and x. And then it needs to multiply out to give me 9, so it has to be a factor of 9, but it has to sum up to -6. So those values would only be -3. So I'm going to rewrite this one more time a little bit differently. I'm going to say it's -1 times x minus 1 times x plus 2 times x minus 3 squared. Okay? So it's really key that we get the function in factored form. Make sure you write yourselves a note to do that. If you get the function in factored form, finding the characteristics is much easier. Okay? All right, so now that I've gotten the function in factored form, let's find our roots. So to find my roots, right here, the roots occur when f of x is equal to 0. So every time I see an f of x, I'm going to replace it with the number 0. So right here, I'm going to say 0 equals -1 times x minus 1 times x plus 2 times x minus 3 squared. So this -1 cannot equal 0, so I don't worry about that. I set x minus 1 equal to 0, so x is 1. This piece right here gives me x is -2, and this piece here gives me x is 3. These are my 3 roots. Okay, so I can go ahead and go up here. Now, that should be a little bit strange to you that we end up getting 3 roots, okay? Because this is x to the power of 4. So why do I get 3 roots? Because this root of 3 actually occurs technically 2 times. How do I know it occurs 2 times? Because of this squared right here. Okay, and we're going to talk about what this squared does to our graph momentarily. So now that I figured that out, the next thing that I need to do is find out what my y-intercept is. So let's go ahead and do that. I'm going to squeeze my y-intercept work in the side right here. Okay, and remember the y-intercept occurs when when x is 0. So I'm going to find f of 0. So when I plug in all of this information, I end up getting f of 0 is equal to 18. So therefore, my y-intercept is 0, 18. Okay? Lastly, my end behavior. We spend a lot of time talking about end behavior. If you remember, if it's x to the power of 4, it could look something like this. This is just a random example. It could look something like this right here. It could also look like a parabola that opens up or opens down. Regardless of whether it looks like this or like this right here, it's really important that we see that it's approaching the same spot in both sides of x. So for small values of x, this is approaching negative infinity, but it's also approaching negative infinity on the other side. On both sides of this graph, it's approaching positive infinity. On both sides of this graph, it's approaching positive infinity. On both sides of this graph, it's approaching negative infinity. Okay, so what is my end behavior going to be specifically for this graph right here? Well, my leading coefficient is negative, which means that it will open down. So that means that it's not going to look like this or this. It's going to either look like this or like this, or something a little bit different. It's going to lean more towards this because I know I have a bunch of different roots. This only has one root. Regardless, as x approaches positive and negative infinity, as x approaches negative infinity, y approaches negative infinity. And as x approaches, positive infinity, y also approaches negative infinity. So I know that it's basically just going to open down. Now that I've gotten all those characteristics, graphing out my function is so much easier. So let's go ahead and label our axes. I'm going to label this x, I'm going to label this y. And I think going by ones for my x-axis should be sufficient. But going by ones on my y-axis is probably not as good of an idea, because I will tell you shortly. Actually, I want to talk about our roots first. So if we have our roots right here, we know that we have a root that will occur at 1. We know that we have a root that will occur at -2, and we know that we have a root that will occur at +3. So at this point in time, I already have 3 values that I can graph out on my graph, okay? And I apologize. I said we don't want to go up by ones on our y-axis, and I went up by ones. We want to fix that, okay? Now, for our y-intercept, we know that our graph, don't draw this on your paper, but we know our graph is going to look maybe something like this right here, because my end behavior says it's going to negative infinity on both sides, as well as the fact that we have our roots in this area right here. Okay, it's not going to look like this on the actual graph. I'm saying it's just going to look like this general shape. Okay, so now that I've done that, I need to figure out, well, what are my turning points going to be? Or at least, what are some points in between my roots that will allow me to do some turning to go from one root to the next? Okay, well, my y-intercept is an important piece of information, but we also have some coordinates here. We figured out some coordinates when we were using the remainder theorem. So it actually is going to serve us 2 purposes, okay? So let's see right here. We know that this is going to go all the way up to 32. We know this is going to go all the way up to 18. So I'm thinking going up by ones is probably not a good idea. Maybe we should go up by 4s, okay? So 4, 8, 16, 20, or sorry, 4, 8, 12, 16, 20. So I'll put a 20 here, and then I'll put a 40 here. And then here, 1, 2, 3, 4, 5, I'll put -20 here and -40 here. So let's go ahead and graph out our y-intercept first. And we know it occurs at 18. So at 0, 18, I know it's going to go up here. So again, I know it starts on the bottom, it goes up, it's going to have to go back down. Somewhere it's going to have to turn back around, and then it's going to have to turn back around again. So I've got one point in between these 2 roots, so I'm good to go for there. So since I know that f of -1 is going to be 32, I can also graph out that value here. So -1 will go all the way up until 32. So I'm going to put a 32 right there. And then I also know that f of 2 goes down to -4. So I'm going to go to f of 2, and I know it goes down to -4 right here. Now, one thing that I want you guys to understand right here is that this x minus 3 to the power of 2 has an order of 2. So this right here has an order or a multiplicity of 2, which means right here, if you notice, this is kind of like a linear factor, right? This is also a linear factor, but this one right here is a quadratic factor. So let's talk about what that means. So when I graph this out right here, I'm going to start connecting my dots right here. I know that it's going to go all the way up to here and then all the way back down to here. And I also know that my end behavior is going to approach negative infinity. So if you notice, if I were to just zoom in on this area right here, it looks like a line. It behaves like a line. As well as if I were to zoom in on this area right here, in this spot right here, my root, around my root, it behaves like a line. And then it turns around somewhere around here, and it touches this root here. But this root is a quadratic factor. It happens twice. It has a multiplicity of 2, which means that it's going to behave like a parabola right here. So that means it's going to go down like that. And now it has the end behavior that I'm looking for, where it opens down and on both sides it approaches negative infinity. So that means that this right here is the graph of my function f of x equals negative x to the power of 4 plus 5x cubed minus x squared minus 21x plus 18. Okay? All right, so let's get a quick definition down. Multiplicity, which is also known as the order, okay, is the number of times a factor occurs. Okay, and one quick thing that you need to understand, well, first of all, let me give you an example. So if I have f of x equals x minus 5 to the power of 4 times x minus 2 to the power of 3, this has a multiplicity of 4, and this has a multiplicity of 3. Okay, so two things you need to know. If a graph cuts through the x-axis, at the root, it has an odd multiplicity. Okay, and then if the graph, or if a graph simply touches the x-axis at the root, it has even multiplicity. And next time I see you in class, we'll talk about why this is true. We'll talk about this a little bit more in depth so you can kind of see and truly understand what this piece of our notes means, okay? So use the characteristics of a polynomial function to find its equation using this graph right here. The first thing that you need to be aware of is, I want to know, is this going to be an odd degree or is it going to be an even degree? Well, remember, if it's an odd degree, then it approaches negative infinity from one side and positive infinity from the other side. If it's even, it approaches either both negative infinity or both positive infinity. Since this is approaching negative infinity on both sides, we can conclude that it has an even degree. Okay, so now that I've done that, I can go ahead and start using my roots to help me figure out what my equation are. Well, I know that my roots occur at x equals, right here I know it's -1. I also know that it occurs at x equals 2, and it also occurs at x equals 4. So therefore I can say right here that f of x is going to be x plus 1 times x minus 2 times x minus 4. But this right here gives me an odd degree. So how on earth am I going to get an even degree? Well, right here, this behaves like a linear function and it cuts through my axis. So this is going to be to the power of 1 because it's linear, right? It behaves like a linear function. And then this one right here also behaves like a linear function. Linear functions are to the power of 1. But this one right here behaves like a quadratic function. So this is going to be x plus 1, to the power of 2. Okay? Now I have 2 plus 1 plus 1, which is 4, so now I have the even degree that I am looking for, so that looks promising. Again, remember, if a graph touches through the x-axis at a root, it has an odd multiplicity. So it only, if it cuts through it. So it only cuts through it. Here, we need an odd multiplicity. Okay, how do I know it's 1 and not 3 and not 5 or any other number? Because this is behaving right here like a linear function. This one, however, is behaving like a quadratic function, but also if it touches the x-axis at a root, then it has an even multiplicity. Okay, but the thing is that I don't know what my a value here is. So that's the only piece that's missing. Once I figure out my a value, I'm done. I've gotten my equation. Well, how do I find it? I have one piece of information I haven't used yet. 1 is my x value, and here, this is my y value. So I can plug in that information. So instead of f of x, I can replace it with negative 12. Okay, I don't know what a is, but instead of x, I can replace it with 1, and then I can solve for my a value. Okay, so now let's just go ahead and evaluate this and see what we end up getting. So we get negative 12 equals a times 2 squared times negative 1 times negative 3. So we get negative 12 equals a times 4 times, this turns out to be 3. So we get negative 12 equals 12a, right? Which means that a is equal to negative 1. Well, now I have everything I need in order to be able to figure out my function. Therefore, my function is going to be f of x equals negative 1, or just negative, x plus 1 squared, x minus 2, and x minus 4. Okay, and I can go ahead and multiply it out if I want it to look like this format right here, but if you leave it in factored form, that is totally acceptable, nothing wrong with that, and that's our answer. Okay, see you next class.